Hello guys. So in continuation with our part 1 of IP version 6, let's move to the other parts of IP version 6. So before moving it, I just wanted to give you a small revision of what we are talking about. So we are focusing on IP version 6. So we started with the basic details of IP version 6, the size and how it operates, what is the functions and all those stuff. So we are trying to learn, or we are trying to understand the concepts of IP version 6 comparing with IP version 4. Because we are good at IP version 4, so we are looking at IP version 4 for a long time, so it is very easy for us to get the concepts, understand the concepts of IP version 4. So based on that, we are comparatively studying IP version 6. So in our first part, I was talking about the size of IP version 6, which is 32 bits, and it has been increased in IP version 6 of 128 bit. This one is very extensive. It has a extension header, that is an advantage of it. And the structure of IP version 6, we were discussing about the structure, like what are the necessary headers the IP version 6 is carrying. So in IP version 4, it is represented with 32 bits, so which is divided into 4 octets. Each octet, that is 8 bits, 4 octets. Here in this case, it is divided into, or it is separated with 8 portions, 8 parts. So 1 2 3 4 5 6 7 and 8. So you have 8 parts in a, or 8 portions in a IP version 6. So each portion, you will be having 4 parts, 4 hexadecimal value, which means each hexadecimal value represent 4 bits of binary value. Okay, so it is going to be 16 bits. One part is 16 bits, so you have 8 parts which constitute 128 bits. So this is what we were discussing. And the next thing about IP version 6 is it is a hexadecimal. It supports hexadecimal, so the value will be from 0 to 9, and then from A to F, so which is 0 to 15. So totally it supports 16 bits. So these are the things which we were discussing in our previous portion. So from here, and the other thing we were discussing is about the NATing. So IP version 4 supports NATing because it has to convert the private IP addresses which are not rooted, or the non-rooted IP addresses which are used locally, to route with a public IP address, or to translate with a public IP address in order to route throughout the internet. We use NATing for IP version 4, whereas here in IP version 6 we don't want to use NATing, but however NATing is supported only for the purpose of communicating with an IP version 4 networks. Either it is on the other end of the network, or if it is within the internet, whatever it is. This is what we call it as a dual stack. That means working with the IP version 4 and version 6, the compatibility of working with IP version 4 and IP version 6. So with this introduction, so we move further. When we are talking about IP version 6 addressing, in IP version 6 addressing, you have different types of addressing, like what we have in IP version 4. You have unicast, multicast and broadcast in IP version 4. Here in IP version 6, you have unicast, you have multicast, and you have anycast. You don't have broadcast, you have anycast. What is this is, let's discuss about these 3 types of IP addressing schemes or IP addresses. Now, so first, any cast is any IP address, any format of IP address which or any IP addresses which you define, and you can use it as an anycast IP address. Okay, so this is anycast. Maybe you use for a private purpose, you want to issue a separate IP address, so something like that, then you go for a anycast. You know what is a multicast? Multicast is to send information from one source to a particular group of host. So in this case, multicast will be used for purposes like communicating with the nodes, okay, communicating with the nodes, or communicating with the routers, or communicating with the routing protocols, something like that. So for a specific communication from one source, or from one source to a group of destinations or group of hosts, then we go for a multicast. So in this multicast, either you communicate with nodes, all the nodes which are present within the network, or all the routers which is present in the network, or with some routing protocols like we will be talking about static routing in our upcoming classes. The same way, we also have dynamic routing, like dynamically routing the packets. So we have protocols like RIP, OSPF, EHRP, and all those things. All these routing protocols, the dynamic routing protocols, you know. So for these communications to happen, like RIP communications, EHRP communications, EHRP IP version 6 communication, or for all those things, we go for a multicast addressing. So it has specific addresses, IP version 6 addresses, like you can easily identify that these are for communicating with all the nodes. These IP addresses, they start with, or these are assigned for the routers, communication with the routers. These are for the RIPs, these are for EHRPs, these are for OSPFs, and all those things. Okay, so for example, if you want to communicate with, okay, before that, if you're going to do a multicast IP, if you're going to use multicasting, so multicast always starts with FF02. So this is what happens whenever you see an IP version 6, and when you see an IP address which has FF02, then it means it is a multicast. So if you are going to use it for all the nodes, then the value is going to be 1. This is for all the nodes. If you are going to use it for all the routers, then you use FF02 :2. This is for router. So the same way you assign for each and everything. Maybe you can just Google it to search what are the different IP addresses schemes which is used for a multicast. During our presentations, I may show you. Maybe for RIP, I think it is FF02 : I think some 7-8 or something like that. Okay, so so you have specific addresses, IP version 6 addresses, which is used for multicasting. So generally for multicasting, this is FF02 is used for multicasting. Okay, so in which, if you are going to multicast for all the nodes, then you use FF01. If you're going to multicast for all the routers, then you use FF02 : 2. Okay, the same way for all the routing protocols also you use multicast. This is the purpose of multicasting. So as I was already telling you, anycast is an IP address. You can use any IP address. Okay, that is what it is, anycast. You can define any address, just you write any address which is of the same IP version 6 architecture, with the structure of the same IP version 6, use the same structure of IP version 6, and then you create any IP address, but you have to specify that it is a anycast. So if you specify it as a anycast, then you can it will consider that address as a anycast address, and it will use it as anycast. Generally we don't we use anycast for domain names, DNS purposes and all those stuffs. Okay, but anyhow, when we are doing our practicals and when we are working with a network, IPv6 network, then you will I will show you a demonstration of those IP addresses. Don't worry. That is first part. This is anycast. The next one is multicast. Multicast, you know that from one source to a specified group of host, you are going to send packets. So in which case you will be doing that, you may be either sending it to all the nodes within a network, or you will be sending it to all the routers which are present in the network, or you will be sending it to or it may be a communication between the routing protocols like AGRP or routing information protocol. These are the dynamic routing protocols. Okay, so we will be discussing about routing protocols in our upcoming classes. We will be talking about static routing, where static routing is just you ask the router to send the packet in this direction, like it is kid, like you know what you ask your kids to do. You give instructions to your kids, right? Isn't it? If you have a kid of 5 years or 6 years, maximum 7 years, you are eligible to give an instructions which could be followed by your kid. Okay, after that it is very difficult. Now if your parents are, or if you are a teacher, as a teacher or as a lecturer, if I am going to instruct you something, it is going to be very difficult to make sure that you follow my instruction as it is, isn't it? So because you are matured enough, I'm not telling anything wrong, because you are matured enough to think whether whatever I am telling is correct or not. Based on your thoughts, then you can proceed it. You decide of your own. You decide it dynamically. So that the similarly dynamic IP addresses, you see the network, and then based on the network's formation, you route the packets. That is dynamically. Whereas static, you statically tell this router, example router 1, please send all the packets to router 2, or please send this network's packet to router 3. So you can specifically tell that is static. Okay, so dynamic routers, how they communicate, they communicate using multicast. Okay, they communicate with among their groups. So they exchange packets like, hey, I'm using OSPF, hey, I'm using RIP, hey, I'm using AGRP. So like that they communicate, and for that purpose they use multicast. So multicast, how do you classify multicast? Multicast is represented with FF02. Okay, so when it is a multicasting address, then like in even IP version 4, we also classify. We have class A, class B, class C, and then we have multicasting address, isn't it, right? The same way here also we specify multicast, like FF02 range is a multicast address. For all nodes you use FF02::1. Okay, for all routers you use 2, and it goes on like that. Okay, this is multicasting. Now let's move into unicast. Unicast IP addressing is one thing which you have to concentrate on, and you have to understand more about unicast. So when we talk about unicast, we can specify, or we can classify unicast with different levels or different categories. Like in IP version 4, we have different addresses, like we have a default address. Okay, then we have loopback address. Then we have the other addresses. So like that we also have classifications with IP version 4. The same way for IP version 6 also we have that. So we start with the first classification, that is all zeros, just colons. Like I was telling you how to compress and decompress IP addresses. Like you have a successive zeros, then you can represent it with colons, isn't it? So if you have all zeros, okay, if you have all zeros, then it means we call it as a unicast address. Okay, what unicast address it is? We call it unspecified unicast address. On unspecified unicast address. What is this unspecified unicast address? It is simply all zeros. Okay, it is like our default roots which we use in our IP version 4. Like, what is a default root? You say that all zeros, okay, quad zeros, that is a default root. So when we talk about static routing, you know, we come across this default roots. Okay, don't worry. So what this means is, whatever it's a quad zeros. That means whatever is whatever packet is coming, you just send it here in this case. The same way, it is also similar to that. It is like default root which is used in your IP version 4. So this is one category of unicast IP version 6 address, where you specify with all zeros. It is actually all the bits there are zeros. Okay, so then it means it is a unspecified unicast address. The second thing in a unicast address, second classification we can make is the next one, that is all zeros, the last bit to 1. Okay, like in IP version 4 we say that in order to identify the host part, the network part, the network ID, the host ID, first usable, last usable host, and all those stuff, you know, we do that, isn't it? The same way here, if you have all zeros, then it is an unspecified unicast address. And if you have all zeros but the last bit to 1, the last portion to 1, that is, it is 0 0 0 0 0 0 0 1. Okay, so it is not separated by dot, divided by dots, it is by colon. So in this case, this one we call it as a loop back. Okay, so we call it as a loop back unicast address. The same way in IP version 4 also we have loop backs, but we have one block of IP address which is reserved for this loop back in IP version 4. Like the range is 127.0.0.1. By default we use this as a loop back value, and it goes on until 127.255.255.255. This entire block, which is a class B, isn't it? Which is a class B. Which one? This one, you know, it is like lots of IP addresses, isn't it? Sorry, class. It's a loop back, isn't it? So this one, the same way, similar to IP version 4, IP version 6 is also having a loop back address, but it is the last bit to 1. Okay, so the third classification in a unicast IP address is what else we have in unicast? Yeah, very important thing, we always use it, that is link local address. Link local unicast address. What is this link local? It is just to identify the links, local links. Okay, we can say like that. Or, you know, if you're new to a place, if you're new to a class, maybe you're joining the school for the first time. You don't know your neighbors, you don't know who is next to you, what's the name and all those things, right? So you go and introduce yourself, isn't it? You try to link yourself, like hi, I'm Nitish, I'm coming from so and so place, isn't it? So maybe like hi, I'm Nitish, I'm coming from SA1 region of SA1 area of Swansea. So then I would be looking at, is there anyone else from SA1 so that we can be friends? Or is there like, maybe, you know, when I come to work, then I will ask, is there anyone who is passing through this place so that I can also come along with you? Can you give me a lift? something like that, isn't it? So that is the purpose of link local here. Actually, in IP version 6, the link local address is used to discover the neighbors, okay, to just go and discover who are the neighbors. That is a link local. So link local here is specified by FE80, okay. FE80 is for link local addresses. So what is this address? This address is used for discovering the neighbors, okay. And then you have another category of unicast address, that is all rest of all these three categories. That's the fourth one. We call it as a global unicast address. Global unicast address. Generally, global unicast address starts with 2000, okay. So whenever you see an IP address with 2000, 2001 and so on, like that, you know, it is a global unicast address, okay. And that is like our public IP addresses, similar to that, okay. So this is unicast address. So shortly I revise what we were talking in our so far. So we are talking about IP version 6 addressing. IP version 6 addressing, okay. So IP version 6 addressing is a 128-bit. The size is 128-bit. The main purpose is to mitigate the depletion of IP version 4 addresses, or the drawbacks, to mitigate the drawbacks of IP version 4. And IP version 6 actually does it very good. It covers all the drawbacks of what we are facing in our IP version 4 addressing scheme. So it is 128-bit. It is classified, this 128-bit is rearranged with 8 portions. You have 8 portions rearranged, 1, 2, 3, 4, 5, 6, 7 and 8 portions. Each one is going to have, each portion is going to have like what 16 bits. Each one is of 16 bits. So when we say 16 bits, it is not represented in binary, or it is not instead it is represented in hexadecimal. So that means you have 4 values here, 4 hexadecimal values, which constitute 16 bits. So each part have 4 values. So it goes like that. So typically your IP addressing scheme will be, since it is a hexadecimal, it will be ranging from 0 to 9 and A to F. So it will be like 2001:5139 F00A :1234 :0000 1 2 3 4 5. We have another 6 7 8 3 parts here, E B C F D E F C 7 8 9 0, something like that, okay. So this is I'm just writing it just like that. So you have 8 parts. All these 8 parts constitute an IP version 6 structure. The other thing we were talking is about the NATing. It does not have NAT, but it supports NATing in order to work with IP version 6 and IP version 4. Okay, this one we call it as a protocol translation, NAT protocol translation, and it is also a dual stack. Okay, dual stack in the sense it supports both IP version 4 and IP version 6, right? Then we were talking about the headers of IP version 6, which is very simple. It has only the basic, whatever is required is there, and if you want to add additional things, then you can add additional header files to that. So this part of working is called as an extension header. And another thing also, I think I forgot to tell about, it is also very good at security. Okay, the security functions like encryptions and all those stuff is also inbuilt with IP version 6. Okay, so maybe when you are studying more about security advanced security and all those stuff, then you will be also looking more closely with the IP version 6 security things. Then we were talking about the how to represent the IP address. So when we are talking about the IP structure of IP version 6, there are three important things which you have to understand. One is it is case insensitive. It is not case sensitive. It is not case sensitive. Okay. Then the leading zeros. Okay. So you can omit the leading zeros. When I say, so for this one, you won't get confused. When you start using it, then it won't confuse you, like now how comfortable you are in using IP version 4. The same way you can become comfortable in IP version 6. So when you have 0 1 0 0, that means the value of 100 doesn't change if you either include the 0 or delete the 0, isn't it? That is the leading zero. So you can omit the leading zeros, and then you can replace the successive zeros at least only once with a double colon. Okay, the successive zeros you can make only once in IP address. I explained you in part 1, isn't it? So these are the three important things which you have to understand when you are talking about or remembering about the structure of IP addresses. This one we call it as a compressed version or a decompressed versions, something like that. Okay, either you put it maybe in today's lab session you will be doing compression and decompression of IP version 6 addresses. Okay, enhance it, elaborate it, and make it short, whatever it is. So these are the things we were discussing. After that we moved into the types, like you have unicast, multicast, and like in IP version 6 you have broadcast. Here you don't have broadcast. Instead of that you have anycast. So what is anycast? You use any IP address and then you specify it as hey, I'm using this one. Okay, I want to use this one, but this is anycast. You specify that, then it will consider as anycast, and you can use it. But generally we don't practice it. The general purpose of using anycast is for DNS, something like that, specific purposes. Okay, then the next thing is multicast. Multicast, you know what it is. So from one it goes on to a specific set of devices. Okay, so this multicast, it can be used for purposes like communication, establishing communication with nodes, establishing communication with routers, or establishing some sort of communication like protocols, routing protocols you use, or some other specific purposes you use multicast. Okay, so how do you specify multicast? We specify multicast with FF02. Okay, so if you are going to use it for nodes, you say 1. If you are going to use for routers, you say it as 2. Okay, for protocols, you have different protocols. You have RIP, you have EGRP, you have OSPF, and all those things, right? So for each one you will be using it. So when you are going to study about these routing protocols, then you will be knowing about what are the addresses you are going to use. So this is the purpose of multicast. And the third one we were talking about is unicast. Unicast has a lot of categorization, classifications. Like the first thing in unicast, you represent with all zeros. Okay, so what is this all zeros? You say as unspecified unicast address. Why? What is this? It is literally all zeros. Okay, like we use default routes in our IP version 4. The next one is all zeros, but the last bit to 1. This one we call it as a loop back. Okay, so in IP version 6 also you have loop back. Okay, so loop back unicast address. Then the third one is what we call it as a link local. Okay, so you know about it. We will be using this for every time. So this one is specified with FE80. So if you are going to have if you're going to take a multiple choice test, if you're going to take a Cisco exam, certification exam, or like this, maybe you get a question of giving an IP address like a FF02, or it gives the FE80. They will ask you which one is a unicast, which one is a link local address, which one is a multicast address, some questions like this. Okay, so that is link local. So what is the purpose of link local? To discover neighbors. Okay, to just discover your neighbors, you use link local addresses. So we will also talk about this one, link local, the performance of this one, link local with the IP version 6. Then the final thing is here is global address. What is this global unicast address? Okay, so let's see. So the next one is global unicast address. What is this global unicast address? It is the rest of this unicast addresses classification. It is called as a global unicast address, which starts like 2000. Okay, so these are the classification with IP version 6, right? So after this, I would also talk about another one concept. With that, I think the description or demonstration of IP version 6 is fine. Then we can move to the next level. So what happens is, if you are going to use a IP version 4 and you have devices here, you are going to communicate. Maybe what you do is you ping from one PC to another PC. You ping from one PC to another PC for the first time. Okay, you use a IP version 4. So what happened? This is 10.1. Let's say this is 10.2. This is 10.3. Okay, so when you ping, when you connect it first, when these guys don't know each other, what happens is, when you ping, it has to do this ARP and all those things. It has to go find out where this person is. From there it has to come and talk, reply to you. So in the meantime, what happens is, the first packet will be dropped. That is why when you make your ping 10.1.1.2, the first one initially will drop, will say failed. Okay, then it picks up and it gives a successful ping. Okay, this is because it has to take some time to go and identify its neighbor. But in this case, in IP version 6, it is not that. If you have an IP version 6, let's say R1 and R2, you have two devices. If this is configured with IP version 6, IPv6, immediately when it is configured, it will not wait for your ping command or something like that. Immediately it will just go and discover its neighbor. Why is it discovering its neighbor? Not to identify, the first stand is not to go and check who is residing next to me. Not it is that case. First thing is to avoid duplication. Okay, it is to avoid duplication. That means it will be having an IP address, like I was previously talking to you. You have two parts of two portions in IP version 6. One we call it as a one is a network portion and the other one is a host portion. That is, here we call it as a global ID, and the other one is a interface ID, isn't it? So these are the two things we have, right? So what happens here in this case, you are going to assign the global ID, and the interface ID it can dynamically get assigned. Okay, we will talk about it in a couple just after this one. Okay, how it is dynamically allocated. So what happens is, when it has an IP version 6, then it has to think that, or it has to first confirm that my address belongs to me. It is not existing anywhere else, or it is I'm not duplicated. Okay, now to avoid this duplication, it will first it will establish communication, say, hey, I'm having this IP address, maybe 2000. Okay, is there anyone having that? Is there anyone who has a problem with that? Like, hey, my name is Nitish, is there anyone having problem with my name in this class? But generally we have that, right? Not for names like Nitish, but some common names like John. We will be having similar names, 2 or 3 Johns in a class, isn't it? So it's a duplication, but actually it is not duplication. No, I'm just giving an example. So it has to first, okay, even if we have 2 or 3 Johns, then we add their surnames and then we call them, isn't it? The same way here, first it will check for its duplication. Once it says that, oh no, no, we are not having any issues with your IP address, you can still keep your IP address, right? So now it is confirmed, hey, oh, okay, so this is my IP address, no one is having this IP address, so this IP address is confirmed to me, I can take this IP address. This is the first purpose why it established communication. And then the second purpose is to find out who is linked to this particular node or router. Okay, who are you connected with? Okay, so that one can be identified. That is typically a neighbor discovery. Okay, so for this purposes, IP version 6 will establish a communication, right? So in that case, the opposite side don't even want to complete its link local. Once this one is set, or this one end is confirmed without duplication, then it will automatically assign it can pick up its own link local addresses, right? So this is the advantage of IP version 6. Like in IP version 4, the first packet will be dropped. When you connect it, it will take some time, but in IP version 6, it will pick up just like that. So that is the advantage of IP version 6. So the same thing in IP version 4, you will be using IP version 4, you will be using this ICMP packets, isn't it? So in IP version 6, you will be using ICMP v6. Okay, we will be using ICMP version 6, right? So that is the advantage. So it also detects the duplication, checks for duplication, and also it helps in discovering. Okay, so how it discovers, it discovers with the help of a link local address, right? Okay, so the next thing what we have to talk is about this interface ID. So what happens is, okay, so now this, I think this with this we can complete this description. From there we can go into our PowerPoint presentation. So here I have already told you that it is a 128-bit, in which 64 is for the global part, global identifier, and the other 64 is for the interface identification. Okay, so I told you already this one. So what happens in this network part? How it works, this network part? See, what happens is the first 16, that is a /16, it belongs to someone like it is called as ARIN, American something. Okay, how it is being decided? It is being decided, or it is being approved by this IANA. What is IANA? I think in the first class we were talking about IANA. IANA is the standard, the service provider, or the one who is in charge of the IP addresses, isn't it? So IANA. So they say that the first 16 bits are assigned for ARIN. Okay, fine. Then the next one, that is /24. Okay, it is /24, not /32. Okay, so generally students get confused with that. This one we call it as a top level aggregation. Okay, TLA. We call it as a TLA. The second one, /24. Then the third is /48. Okay, so this /48 we call it as a next level aggregation. We call it as a next level aggregation, NLA. We call it as a next level. So in this 64, the first 16 it is for ARIN, the second one, the /24 is for TLA, that is top level aggregation, and the third one /48 is for the next level aggregation. Okay, and then the final, this entire 64 /64, it belongs to SLA. What is SLA? SLA is SLA is site level aggregation. Okay, SLA is site level aggregation. Okay, so this is how the global identifier is classified, right? So now we go into this interface identifier. So when you are going to talk about this interface identifier, it is a very interesting. What happens is this interface identifier, it can be dynamically assigned. Okay, I'm not talking about DHCP, or I'm not talking about DHCP version 6. I'm talking that generally in IP version 6, the identifier part, the global part, like, you know, when we started with IP version 6, I told you that this global part you are going to assign, and the interface part can be dynamically assigned, isn't it? So here, this interface part you can dynamically assign. How are you going to dynamically assign? You can dynamically assign with the help of a concept. Let us discuss about that concept now. Okay. So I guess now you are clear about the global identifiers and all those things, isn't it? So the next part here is we are going to talk about this interface identifier. So I said that the interface identifier can be dynamically assigned. You can dynamically assign. So how can we dynamically assign? We use the standard which is called EUI 64. Okay, EUI 64. Okay, what it does is it will help to dynamically assign IP the identifier part, the interface identifier into the IP version 6. How it happens? We call it as auto configuration. It will automatically configure. So how it happens, see here, you have 64-bit. It is going to use the MAC address. The MAC address is unique, right? For the MAC address of any interface is going to be unique, isn't it? So it is going to take the MAC address and assign it for the interface ID. Oh, okay, wait. But the problem is, MAC address, we have already discussed about MAC address. It is only 48-bit, isn't it? But here we need 64-bit. So how can we match what is going to be the balance 16 bits? How the balance 16 bits is going to be matched? So this is how it happens. This MAC address, this MAC address is divided into two parts, isn't it? One part, it has the manufacturer, vendor details. The other one, it has the interface details, right? Two parts, right? 24. So it will take the first 24-bit, that is the vendor part. It will keep it. It will separate both the things. Then it will keep the next 24-bit, that is the interface part. It will keep it. Okay, this is a vendor part. Now here we need the balance. We need is 16-bit. So what it will be doing is, it will take, or it will add FE, which is 16-bit, isn't it? So we already were talking how each hexadecimal is valuing. Each one is valued for 4 bits, isn't it? So 4, 8, 12, 16 bits. So it takes a MAC address, it divides the MAC address, or it takes the vendor part of the MAC address and then adds FF:FE, which is 16-bit. It is by default, it will take, if you are going to go for a EUI 64, it will automatically take this FF:FE, and then it will add the interface part of the MAC address, which makes that this one is going to be unique. This interface ID is going to be unique. Okay, so this is how IP version 6 IP addresses are dynamically assigned, or the interface IDs are dynamically assigned. So that means it is a stateless IP configuration. Okay, what is stateless? Stateless is dynamic, that is automatically configured. So that means is there any chance that I could go and manually configure, like a static configuration? Yeah, you can assign it. So that one we call it as a stateful. Okay, so I think I have covered almost everything about IP version 6. I hope you are clear. If you have any doubts, please ask me the doubts. Okay, so before completing it, I just give you the points to remember. We are talking about IP version 6. IP version 6 is 128-bit. It is represented with the hexadecimal. What else? It has 8 parts, 8 portions of IP addressing. So it is represented from 0 to 9 and A to F. It is being represented by that case. So when you're going to represent an IP version 6 address, it is not case sensitive. Leading zeros you can omit, and then successive zeros, at least once successive zeros you represent with double colons, right? And then we were discussing about its header files. It is a simple header file. That means it only contains the basic informations, like it has the version, it has the source IP, it has the destination IP, it has the flow table, hop limit, all those very limited thing. Okay, and what happens if it wants to add, it can still add whatever you need to add for that header. Then you can add it, like authentication header, you can add it, TCP header, you can add it. Okay, security header, you can still add it. Okay, so this type of things we call it as a extension header. This is what IP version 6 is all about. It is a extension header. Okay, and then we were talking about unicast. So in unicast you have all zeros, that is a unspecified unicast, and then you have loopback unicast, loopback address, that is all zero is a unspecified unicast, all 0 last bit to 1 is a loopback, and then you have link local. Which is represented by FE80, right? And then you have a global unicast address, right? So global unicast address, it starts with 2000, starts from 2000. Okay, and then you have a multicast. And then you have anycast. You don't have broadcast, you have anycast here. This is about IP addresses. So the IP version 6, like I said, it is of 2 parts. Like I said before, it's of 2 parts. You have 1 2 3 4 5 6 7 8. Okay, or let me do it equally. So this one is represented with 1 2 3 4 5 6 7 and 8, isn't it? So it has 1 2 3 4 5 6 7 8 parts. Okay, so in that 8 parts, that means each one is having 16 bits, right? So out of which the first 4 parts, these 4 parts we call it as what? Global identifier. And this the next 4 parts we call it as a interface identifier. This one we call it as global, and this one we call it as interface identifier, like what we do it for IPv4, like host and network part. Okay, here it is global and interface part. So this one is 64-bit, this one is 64-bit. So how the 64 is classified? The first 16, it belongs to ARIN. Okay, and then from this until 24, it belongs to TLA, that is top level aggregation. Then the third one, 48, it belongs to a next level aggregation, NLA, next level aggregation. And then 64, which belongs to site level aggregation. Okay, so this is a site level aggregation, this 64/64. This one is an interface. This 64 bits remains for the interface ID, that is for the host and all those things. For this one, you can either dynamically assign or statically assign. You can still dynamically assign or statically assign. So if you say static, then it is a stateful. Okay, you say stateful, it is static. Dynamic, it is stateless. So we use UI 64. Okay, what happens is, this is going to take the MAC address, 24-bit MAC, MAC's vendor information, and 24-bit MAC's interface information, and then it is going to add what? FF : and FE. It adds in between, it becomes a unique interface ID, right? And then the neighbor discovery in IPv6 is also very easy. It will instantly pick up the neighbor discovery because once the IP is configured, once the system is up, immediately it will check its neighbor. Why? For two reasons. One, it's to avoid the duplication. So first priority is it has to confirm that name belongs to him. So it will ask, hey, I'm using this AABB. Is it a problem for you? Is anyone having the same thing? Then it's no, we are not worried about it. You can have it. And then it will say, okay, then now I confirm that I am AABB, right? So for that purpose, and then for the next one is to discover the neighbors, right? So this is the structure of IPv6. So from here we move into doing some of the lab exercises.